people sitting here with so much love disappointed. But when Dr. Ramarao spoke about the luminaries who gave the talk here, I become nervous. I don't think I deserve to stand here and give a talk. I'm a fellow from a small village, so I should stay in the backside. I don't know why I came here. So just to recapitulate, I was telling that I studied PUC in National College. My percentage at PUC was 35%. 1 mark this side, I would have been a farmer, maybe a minister today. So I was very active politically. I come from that background. So I thought in life we are born to lead, that kind of attitudes we had. Somehow, I don't know, I remember the results came in the newspaper in those days. So I was so sure that I am going to fail because I had worked very hard to fail. So then I was plowing my land that day, and my father came and said, "Okay, you're fast, you're gone." No. I said, "Man, something must be conspiring, and I should study." That's how I went to study. Anyway, that's the background. So this is to tell you the way we come. I used to walk 20 kilometers to go to Gauri Business School. That's for 3 days, very hard days. And if not for that national college and that great soul, Dr. Nasimaya, I don't think many of us would have stood here or studied. And the other privilege I have is I'm a neighbor village boy for Nasimaya's place. I've been to his place to see many movies there. Kotal Dine, you remember, there is a Bob Atomic Research Center there. So that is the place I come from. So it's a privilege to stand in front of you for a boy who is to take care of his buffaloes there and talk about some science which I have done. Whatever I am going to talk is the sheer enjoyment I have done, not for earning anything or publishing. I'm basically a theoretical physicist till 1997. I always believed that the longer the equation, holier the paper kind of attitude. So I used to write very complex equations, looked at biology, looked at all kinds of things. Then I said, this is not giving kick enough, so that's how I moved to engineering side. So it is a different story. So I am going to share what is the enjoyment I got out of this and how it led to what all the things it led to. So with these few words, I would like to take off on the shockwaves, and I would like to mention that this work, what I am going to present, is by no stretch of imagination is my work alone. Though I have been a catalyst to put this group together, we started with 3 people in 1997 with 1 student who is also from your college. And today is a very famous man. He will probably talk one of these days here. I don't want to preempt by putting his name. He is much, much famous than I am. He was my PhD student, and with him and with 1 mechanic and 1 lab assistant, I started this lab. So today we are probably #1 in the world in this field, and every piece of equipment we have built, and I don't know what is a lathe, what is a milling machine. I have no idea. But all this work is done by these people. I've been just a catalyst. So therefore I would like to put on record that this is not just single person's work. So before I take off, I would like to give some background for those of you who have no idea about this field. I'm sure now everybody talks about aeroplanes, space shuttles. But still, we always work with a number called Mach number. So Mach number is the indicative of the velocity of an object or aeroplane or whatever the bullet is going, divided by the velocity of sound in that media. Sound speed in air is 330 meters per second, and there is a division of these Mach numbers. You generally, in day-to-day life, what you deal is the sonic speed, that is typically about 1,200 kilometers per hour. And you have subsonic, these are buses, cars, and airplanes, everything on something like a few hundred kilometers per hour. Then the Mach number is less than 1 there. Then there is a transonic, and supersonic. Most of your fighter aircrafts, they come under that, and they run something like between Mach number 1 to 5, and the typical speed is 5,000 kilometers per hour. And hypersonics, this is where I work. Hypersonic is the safe bet because nobody will ask you demonstrate it because it is so fast. So I can escape by saying, oh, you don't see that, that kind of thing. And it is always Mach number larger than 5. And just to give you comparison, normal car will be something like Mach 0.06. And for me, because I work in hypersonics, anything, even aeroplane looks like a bullock cart for me. It is very, very slow for me. So I always look at hypersonic is my line of research. And if you look at all these things, this is the comparative study. By the way, how much time I get?
You can take anywhere 1 hour.
1 hour. Okay.
This side, that side.
So when you are bored, please lift your hand. I will stop it there. Okay. So let's look at the shock waves. Shock waves are the ones which occur in front of you, but you are not aware. Because you didn't give much attention to that. These shock waves get generated the moment you have any object which travels at speeds larger than the 330 meters per second. Okay. The moment that happens, there is a wave formed there, and this is the shock wave. This wave is the means of releasing that energy. We will come to that, why and all that thing. They also can occur if there is a sudden release of energy. For example, if a terrorist puts a bomb there, energy is released in such a short time, the whole energy comes out as a wave, and that is the wave which kills the people. Then later on the shrapnel will come, the iron pieces will come, they will kill you later. But the first one which will kill is the shock wave. Okay? So these are also produced in natural calamities, explosions you take, or you take any sort of earthquakes or the volcanic eruptions, all of such things will produce shock waves. Some school of thought believes that the dinosaurs disappeared because of the shock wave created by the meteorite hitting the earth, okay, and that wiped out the life on earth, and dinosaurs were the victims, okay. So if you put an explosion underground, you think you are smart, you will go deeper into the earth and put a nuclear explosion. But remember, this explosion will create a shock wave, and this goes and goes thousands of kilometers it will travel, and anybody who has got a little bit of seismograph will be able to catch it. That's why you just cannot carry out a secret, explosion of the nuclear. Okay? The reason for this is the shock wave. This is the one I am going to talk about. Okay? So these are some examples how the shock waves are generated. If you look at it, the bullets that are going in there is going at supersonic speed. That means it is going faster than the speed of sound. A shock wave gets formed here, and this is the example. This is the explosion you have, and it puts out a shock wave. The idea is behind the shock wave and in between that body, the pressure and temperature will be tremendously high. Okay, this is the shock wave which will occur if you have a spacecraft coming into the Earth's atmosphere, and in front of that the temperature could go to 6,000 degrees Kelvin. That's how you will see the plasma glowing. And accidents happened when Kalpana Chawla was killed because of one of such shock waves. Okay? So these are the ways which I am going to talk and tell how to harness them for our utility. Okay? So these shock waves are also very, very, damaging thing for human beings. Just to give you an idea, let's say Afghan war took place, Iraq war took place, then the soldiers were sent home. Most of them were not harmed, they were quite healthy. But after 1 year, they started losing memory. This is the reason the explosions took place quite far off, though it has not hurt in anywhere. But the pressure which was produced, it went into the skull and damaged the brain, and the neurons started dying one by one, and neurons never get regenerated. And after 1 or 2 years, these soldiers even forgot their own names, they didn't know their house, nothing. Okay? This is called traumatic, brain injuries. So this is the damage the shock waves are going to do on the human beings. Okay? So these are the typical examples of Hiroshima and Nagasaki. And look at the energy what you throw up when you had a bomb. most of the energy came out in the form of a blast wave. This is a shock wave, and that is the one which killed. Later on, the nuclear reactions, radiations came in, but what came first killed, and look at the distances, you can see, it destroyed everything, building, trees, everything. It is because of the shock wave. So this is the strength of the shock wave. It's a real powerful wave which can really destroy life. So this is the shock wave I am going to talk about. Okay? So this shock waves also can be produced in the laboratory. This is where I come into picture. So for example, if you put this is the nose cone of a missile, typical Agni missile kind of thing. If it flies at a Mach number greater than, let's say, 1, this is the wave you get. This is the picture which we have taken in the laboratory at Mach number 6. That is the thing. So now the pressure here is so large, because of the pressure, this body gets pushed back. That's why your Agni can go only at certain speed. It cannot go beyond that because there is a pressure which is opposing it. So if you want to increase the Agni speed, you have to really play there. Okay? So this is the shock wave, and this is another experiments what we carried out. You can see the shock waves. This is just to show that our labs are capable of producing these shock waves. So this is, I'll take you back to a few years back. The shock wave entered into the Indian arena by a professor by name, my name is only Professor N.M. Reddy. Okay, he was the professor, he studied I think some government UC college, then engineer. He was a junior to Radam Narasimha. So he was in NASA, and Satish Dhawan went and personally brought him back, and he established the first shock tube in the country, and this was one of the facilities he had built. This was in early 70s. So that's where the story goes up. And now you can see what we have done. This, I took over the group in 1997, as I mentioned, with 3 people. So these are the facilities what we built. Now, these are the shock tubes what I was talking, which can produce the shock waves. Okay? And look at this. A shock tube is a very simple device. You are seeing a shock tube sitting in here. Okay? There cannot be much simpler device than that. But why did the people not do this and become experts on it? Let's see why it is. So this is one of the facilities what we have built, the 2 of them. So here we have used this shock tube here. From here to here is the shock tube. Then this is a wind tunnel portion. And these are the facilities called shock tunnels. They are so unique. I can produce in these tunnels speeds something like 3 kilometers per second wind speeds I can produce. If you want to produce 3 kilometers, the air supply must come because you are expanding the air to very high speed, it will cool down. So if you don't have a supply of air more than 4000 degree Kelvin, you will have all thing frozen there. So therefore, the shock wave is used to heat the gas before I expand. So this is the shock tube you are seeing. Look at the wave. The shock wave is a devil, but I am using it for my purpose. So I will use this shock wave to heat the gas. Then I put a nozzle there. You can see the nozzle. Expand it to the velocities what I need. So any model I want to test, I put it there. So now this is just, these 2 are HST1 shock tunnel, and this is HST2 shock tunnel. They are capable of producing even up to 4 kilometers per second velocities. Okay? And this is a huge shock tube facility, what we have built. Remember, the reason I show these things are, these are built, designed, fabricated, everything locally. Nothing imported you can see. Okay? That's why the message I would really like to carry to all the people is, science is simple. It is easy to do. Engineering is much more simple. You are seeing the example of that. Can you imagine about 40% of this material is from the junkyards. I have brought the material from junkyards because I didn't have money to do that. And this facility is a unique facility which is capable of producing 7 kilometers per second wind velocity. So the reason is, this can produce temperatures up to 20,000 degree Kelvin. 20,000 degree Kelvin temperature I can produce it in the laboratory. Okay? And this is designed locally by a theoretical physicist, okay, and no idea of engineering, and it is built. And there are only 4 countries in the world which have this. and we are the fifth one to join there. Okay, and it is so classified. No other country will let me touch their machine. Then I go there. So because it has a deep, application into defense and space. So this is the facility we have. Now taken this as the prototype. Now ISRO is going to build a similar kind of facility, but much bigger at 260 crore rupees. That is the cost. Okay, so that they can test all the re-entry machines coming. And this is another tunnel. This is the biggest such tunnel. This fellow can produce about 4 kilometers, but I can test a big missile model sitting in there. And this can be the one which can change our defense status tomorrow, because this is the machine which we are going to use to increase the speed of our BrahMos missile. You have heard of BrahMos missile? It is traveling at 2.5 times the speed of sound as on today. That's the fastest missile in the world, but we want to make it 6 times. And a center has been established with 100 crore rupees budget for that. Okay? And the whole thing will be depending on this facility. And this was built by my people sitting here, some of them. We just, we go to the industry, we say, hey, shall we build it? It's like a fun we take, okay? And these machines are, all over the world, people come and use these machines. This is a message. Please, you don't have to be a genius. You can score 35% in POC and still make this machine. Don't ever believe that anybody tells because you have less marks you are not going to be a scientist. Please don't believe this. It is here. It is here. Okay? We are capable of doing it. So these are some of these slides can be taken out. Okay. So these are some of the facilities we have built. In fact, just to tell you the idea, this whole facility was funded by a naval research of US, and when they want some data, they have approached us. This is, they are supposed to be, confidential, and we are not supposed to talk about it. And they sorted out and came in and said, can you carry out these experiments? And we have completed that. This is the kind, and the important thing is that the home build. So this facility is built by one student, and they're really fascinating. So this is the kind of thing what we have built. And then I realized that, I come from farming community. What is this software doing to me, to my people? When I go back home, the same buffalo is growing, same fellow is doing, same borewell is drying. I said, man, this is not the way I want to finish my life. You see, I have another 5 years to go. I have to do something about it. So that's how we started looking at application of these software. So one of them is, this is my colleague has done. For example, when you do a pencil, when you do the pencil manufacturing, you take the wood, soak it into a polymer at 70 degrees for about 6 to 7 hours, 3 hours. Then you dry it, then you make the pencil. Otherwise, it won't be soft. So now my colleague has developed a device, a sharp tube is there. You put the slates there, all that wood, and put that liquid, one shot, 1,000th of a second, the job is done. So Nataraja pencil is the one which is taking this out. Okay, their production, now they are number 2 in the world, and they will be number 1 in the world. You remember what is the power which is going to be saved and time it is going to save. And it's all simple tubes, okay? Then we also have a problem sitting in India, wood is the shortage, and most of the Northeast works on a bamboo for the construction. And once you use the bamboo wood after 3-4 years, it becomes weak because the termites attack that, and the wood becomes weak, you have to replace it. Then we let us do something about it. So now this is the reactor what we have built. This is also my colleague has done it. You put this bamboo into that reactor, 2 meters of bamboo, then you put a preservative into it. Putting anything into bamboo is a tricky job. You have nodes sitting in there, nothing goes in there. But it will be a baby. You just put it in, put a shock, one shock. The pressure jump is so high, everything will rush in. And this is the patent which got the gold medal in Delhi, EST, Lockheed Martin. And now this is going into market. We are going to market this across the globe. This technology will go. This is turning out to be one of the best inventions what we have in the lab. Okay? So this is for the common man what we are looking at. Then this is the panoramic view of what our lab is. You must come and visit the lab. All of you are welcome to see the lab. And this lab, we fondly call it as Shantiniketan under a roof. Okay. So the reason is anybody can come. If you want to carry out an experiment anywhere in the world, we have sent out this message. India is no more a beggar. We are a giver now. Okay. So all the work we did in this lab has carried this urge to say that we should lead. Otherwise, how long you are a third world? How long? So this is the thing which propelled us to do that. Today, message is out, open in the out, like he was reading, and the president of the International Shockwave Institute, that is the person who controls all the shockwave activities in the world. That's not the important thing. Message given is anybody in the world are welcome to work in the lab. We give them even the financial assistance. We are no more poor. Okay? So the facilities, and so this is the message I would like to carry to you people. Please come and visit and feel proud that we have got this. Okay? So let me start with all these facilities, what is it I am trying to do? Okay? You can say, you like my good friend, our director, says, you fellas only build machines, you don't know what to do with them. That's his friendly remark, he says. I said, hey, hold on, we do something with it. So if you look at this, I don't know if it can play the video. Yeah. Can you see this? Again, this is a missile model, only nose cap I put in, and the air is coming from right to left onto the surface like this, and it is coming at 4 kilometers per second. What happens when such a air goes over the body or into the air when a vehicle moves at 4 kilometers, what will happen? You can see the picture here. Look at it. The air around that will glow. Reason is temperature has crossed 4000 degree Kelvin. The shock wave is in front of it. Between the shock wave and the body, temperature goes to 4000 degree Kelvin. The ionization takes place, dissociation takes place. That is the air which glows. If you don't have a thermal protection system which can withstand this temperature, it will just melt your spacecraft. That's what Kalpana Chawla's accident took place. Today, this is the first time in the country such velocities are generated. That's why I show this picture. This is a record breaking for the country. We have generated this in the laboratory. Okay? This is the beauty of it. Let me see. So, when you do these facilities, we also have to really remember that we have to do something for the country. So one of them, if you look at Gulf War, for example, when you look back, they used to show it like a Pataki, this thing on the CNN TV. There used to be some missile coming, Scud missile is intercepted by Trident missile. Indians people, defense people watched it and they saw this Trident missile had something poking in front of it. So that's when they realized there is always a spike sitting in front of the missile. So this was a puzzle, why is it sitting there? So that's how we took up the interest in that. And we showed that if you can put that spike there, the drag goes down by 50%. That means this vehicle can go at almost like another 30% extra speed. For the same fuel, everything is same. And that is one of the greatest contributions we did. And this became a world famous work. Even today, people talk about this and many people do simulations on this. So this is going to be flown in one of the Agni missiles. That is the ultimate. Reason is, if you can push your Agni missile from Shanghai to Beijing, remember, then the policies, the whole thing strategy changes. Other day when they said our Agni could cover 5,000 kilometers, next day China made a statement, Indians are not competitors, they are partners. Did you read that? So they changed the tune. You see, this is what it means. So this is the kind of means. Now we have a technology to make this. So I can, for the same fuel, same Agni, I can push it by another 2,000 kilometers. This is the technology. And all these came out of my laboratory. I want to take you back to one story. Dr. Dhawan always used to be very, fond of these things. One day we were having breakfast and we took a walk in the audio lab. He said, he put his hand on my shoulder. He said, Dr. Reddy, I understand. Your tunnel can be only 1 millisecond runtime. I understand that, but my scientists don't follow that. So therefore, you have to show that it is there. There is a flow there. Otherwise, before you can, wink, it's all over. So then I came back saying that, look, for me, I worked in the area of femtoseconds, 10 to the power of minus 15 seconds. Millisecond is the eternity for me, but his point was right. Then I came back. Those days, it was very poor time. We didn't have money. We used to put personal money and do research. No government support. Then I said, I have to show a shock wave. That will happen if the vehicle is flying at a velocity faster than that speed of sound. A wave has to stand there. This I have to show it in my tunnel. How do I show? I don't have a camera which can catch it. Therefore, what we thought was we went back to our PUC physics. That's where we really studied physics. We said, if you have a discharge going through this, the light coming out will have the wavelength corresponding to the density there. That's all we studied in physics. I said, hey, let us look at it. So if you look at the shock wave, what will happen? You will have a shock wave. Density here will be different than here. Therefore, there should be a line sitting in there. So you have to strike a discharge. So what we did, we put a, shock tunnel was there, flow was there. How do you strike a discharge? We have no facility to take the picture of that. And whole picture lost only about 1 millisecond. So what we did, we went to a shop in Taylor's, a tailor shop in Malleshwaram. We bought a sewing needle. Okay, he refused to give me a single needle. He said, no, sir, I said, no. I bought all. So we stuck the needle to the top of the test section, and we put a copper plate here, and blew the, discharge we put across, and we just had a discharge there. Then when the flow came in, you could see the shock wave. This was the simplest, most, elegant way of showing the shock wave. Okay? This became so famous around the world. Okay? Sir, science and research is very simple, sir. Very, very, very simple. And science editor is sitting, one of the editorial board members. They were kind enough to put twice, one of these pictures twice at the cover page. And today this work has made us real. Then you do a lot of CFD match with, what experiments we have done. This really projected us into the real research arena. So this is another neatest experiment you can ever think of. Again, I said my drive is to threaten the Chinese. Let me be very honest. Let me be very, very honest. I don't consider Pakistan as a big hurdle. It is the China. So if I can push a bomb, a missile into Chinese middle of the town, they will respect me well. Because I have very close friends there. No, it is not as an enemy I'm saying, it's a strategy. So one day we were discussing, we said, hey, let's do something smarter than putting that stick. Okay? So all that we did was, let us add some more heat into that area where already it is hot. So we said, okay, we have fantastic chemists with us, scientists with us in our lab. We said, let's do something. So we just went to Yeshwanthpur, got this coated with the chromium. Chromium plating pillar, that garage pillar will do it. Okay? So we put it in, then this was totally instrumented, and we ran the tunnel. Okay? It's in millisecond. Look at the drag it dropped. It was here. The moment the heat generated, chromium evaporated, it interacted with oxygen atoms which were ionizing there. Remember that glow? So oxygen atoms were there, chromium oxide formed. It was the exothermic reaction, and it dumped heat there. And that heat reduced, density has to go down because you have P is equal to rho RT. Okay, sir, it is simple physics, sir. You do that. This drag went down. Now we go to Google, open the Pakistan defense web page. You have one page write-up on this. Okay, saying that Indians have this technology. What is the corollary of this? Now, just by coating chromium, your same Agni can go another 2,000 kilometers extra. Okay. This is one of the greatest experiments we have patents on this, and Physics of Fluids brought out this paper. It was the talk of the town, across the globe, things went up. This is the kind of things are possible because those facilities are sitting in there. Okay? So, this is another method. I know it's anything you want to do, there should be anecdotes, otherwise you won't enjoy them. Okay? So I wanted to see, hey, is there a better way of doing this fellow, a little more. So I had a very brilliant boy from Tamil, Andhra Pradesh, very, very economically backward. Okay. But somehow his English was bad, but I could see his brilliance. I said, let us do this experiment. All that I wanted to do was, while the vehicle is flying, if I can push a jet coming out of it, a small air jet coming out, it should do the trick same way. So when I made this presentation in front of all the people, about 30 experts in the world, headed by Professor Narasimha, I can proudly tell, this was in Coorg, that Orange County. When I made this presentation, they said, it is impossible to do this experiment. This was the verdict. So 1 week later, I had the experiment. It was okay. So all that you do is, you just put a jet of thing air there. Look at this jet coming out. The shock wave, which would have been like this, it broke into pieces. That reduced the drag by another 48 to 50%. So this is a landmark experiment. Today, people, how many PhDs have come out of this in China and Iran? Okay? This is the way you can see the drag reduction. See, this is the simplest possible science you can do. But you need to have an urge to do these things. These are some of, say, other tricks of reducing the drag. And this is, if you add little electrical energy in front of the vehicle, it will really reduce the drag. How do you put the energy? All that you need to do is have a space station. You put a laser beam. Once the missile is flying, in front of it, you can put the laser beam. It will do all these things. Then you can really guide the vehicle to go there. So these experiments are carried out. These are the experiments which made our lab world famous lab. Okay. This is one experiment which is the puzzle to me. When you are landing into Mars, what happens is, Mars is only about 40 kilometers. Remember, India is going to put a vehicle into Mars in another few years. They have got already 3,500 crores. You need technology for it. Mars atmosphere is hardly about 40 kilometers, and entering into Mars, you are entering at 11 kilometers per second. Okay? From 11 kilometers, you must hit 0 kilometers within 40 kilometers. So diesel rating the vehicle is a major thing. And atmosphere in Mars is CO2. And CO2 density is so low, there is nothing to stop your vehicle. So therefore, there is a tremendous scope to do research. So we did one small girl from again remote Tamil Nadu, she bought this small magnet, stuck it in front of this vehicle, and ran it that under the Mars conditions. We have carbon dioxide test gas, our tunnels can produce that. We suddenly saw that drag was dropping. Okay, so that means drag is dropping. Remember, when you are entering at 11 kilometers into the thing, heat will be so high, no material can withstand that. Therefore, you need to reduce the heat. Look at this heat reduction. 62% reduction took place in the heat. And these are the things. But puzzling thing is, rest of the world says that if you put the magnet there, the drag goes up. I am seeing drag going down. So this is the puzzle. We are still struggling to solve this problem. But most important thing is, now I can send a vehicle with a small magnet. I don't have to put a heat shield as big as this. So there is a technology which is going to revolutionize the Mars problem. Okay? So all these things come out of these facilities. Future is the place where I want to travel from here to Delhi in 10 minutes to 15 minutes. That is the ultimate goal. Remember this. I want to travel from Delhi to Tokyo in 2 hours' time, and people feel that I should go to have a breakfast in New York and come back for the dinner. Okay, this is the future. For that you need one engine. This engine is what we are dreaming is called a Scramjet engine, supersonic ramjet engine. All that you need to do is, this is your aeroplane, you put a box there, that's all you need to do. No moving parts in it. All that you need to do is inject kerosene into it. That's all. And it is flying at Mach 5 or 6, and the air gets decelerated, enters here, and the temperature, because you have decelerated that 5,000 kilometers to 500 kilometers speed, the difference in the kinetic energy becomes heat. Then if you put kerosene or hydrogen into it, it will catch fire. Because of the energy deposition, pressure goes up, then that high pressure expands through this, therefore the thrust comes the other way. This is called Scramjet engine. Believe me, in last 50 years, people, trillions of dollars have gone into it. They have run this engine only for a few seconds. So the whole world is struggling to do that. And this is the engine designed by our DRDO, and their dream is to take this vehicle, put it at 30 kilometers, put the engine out and fly it for 20 seconds. Because if you travel at that velocity, steel will evaporate like that. So you have to, make new materials. All that research is linked to this. And that whole thing is, this is the engine. Can you see? That engine is just a box. So I tell my students, if you can understand this small rectangular box, your career is done. Nothing needs to be done more. Okay? This is the kind of research which is being attempted. This vehicle, what India is designed, is to go and put a bomb at about 5,000 kilometers and come back. That is the hypersonic vehicle which we are designing. Another few years we will be testing that vehicle. This is anyway DRDO job. Remember, if you recollect, we sent a satellite and it stayed in space and came back after 10 days. And this is the sequence of events. And if you look at this, this is the model of that same vehicle. This we made it to fly it actually in a facility. I couldn't fly this in India, so I took it, we did it in Japan. But all the measurements of the rest of the how much heat comes onto it, what is the heat shield you need to do, were done in the laboratory with us. And this is the most important contribution. So when the vehicle landed at 10 o'clock or so, when it came back, that was the first time India demonstrated recovery. And Nellore, it landed at 10, and 10:15, a few minutes after that, we got a call thanking us for contributing to this. So it all came out of those facilities. And this is the work what we have done. You put all the heat sensors. Remember, the sensors, each sensor, if you want to buy, this is a platinum sensor, 600 euros is what you get. You have to pay. And they don't sell it to you because this is a military sensitive. So we have figured out how to make. These sensors are made day in, day out in the laboratory. And we have taught Japanese to do this in exchange for some technology. Okay? So now we see platinum prices have gone up thrice now. Therefore, I can't afford platinum anymore. So that's why we are going to do carbon nanotubes. Time doesn't need that. So our research really develops into material science, all kinds of things. Okay? This is the future vehicle. We are going to put 2 human beings into space. This is the human in space program. And they will stay in the orbit for a few days, then they will be brought back. This will be the first human experiment, and we are going to carry out all the measurements on this. What should be the thickness of each sheet, everything will come out of our measurements. Okay? And remember, that is the beauty of it. All those machines from the junkyard material are the one which produce this data. Okay? And no other country will do it for you, because that's the sensitivity. So now coming back to science, what we do, you have this 20,000 degree Kelvin temperature available to you at 500 bar pressure. Imagine if you put carbon atoms, graphite, it should become diamond, isn't it? So that is the research we do. I have very strong research going on in the material science. So one of them is this, we just put zirconia, and you can see a lot of things happen. You can see originally it was like that. Then this is the facility. I told you about 7 kilometers string. So you put the material here and I run this tunnel and the material will undergo this, and this has become so famous today. Israelis are using it. Professor Steve is using his research, first paper jointly we sent out, and the Australians are using. Any material science person wants to do work, they dream of having this machine. Okay? I am not going into physics of it. So now, let us say I have this shock tube, It is capable of producing to a few thousand degree Kelvin. What happens if I put some chemistry into it? Why not I do some chemistry? You see, this is where chemical kinetics is a huge branch. High temperature chemical kinetics. All that you need to do is put the chemical here, and you can send in a shock wave, reactions take place, you measure the products what you got, then you can give the whole theory of how the reaction has taken place. This is very important for missiles program or space program, and you can standardize these chemicals before you use it as a fuel. Okay, so we have built these facilities, and this is the chemistry laboratory. You can see the data which came out of these labs has become so famous. Internationally, it has been accepted as the standards for some reactions. And this is the kerosene, remember? Now J.P. Chan is the kerosene which is running all the engines, and now future is going to be very difficult because of the pollution it is doing. So now they are replacing that with a natural product called kerosene, free kerosene. And this kerosene, India is producing herbally, okay? They store, just the story, I don't know how far it is true, Indians smuggled half a liter of this from Russia. And they reverse engineered in Kanpur and produced. But you're not as smart as you think. You have synthesized and copied, but you don't know the reactions, how it reacts. So that's where we come into picture. We iron out all the chemistry. The expert is sitting, Sharath is the expert on that. So he's doing all the chemistry and he fits in the data, which will be useful for the argument. Let me come to the inventions, okay? You see, if you go back to this facility, I was just showing you here. Look at this. What do you have? You have a tube here. There is a 20 kg piston. You push this piston. There is a shock tube here that is producing the shock wave and the temperature. If you look at it and shrink it, it looks like a syringe, isn't it? Medical syringe. That's how the thought process came. Okay? So then what I did was, I sent my colleagues sitting here to buy the syringes. So all that you need to do is take this syringe, remove that needle, put a plastic sheet there. Okay? And then you just press it. Then you see a shock wave coming out. I don't know, the light is too much. You can see a wave sitting in there. This is the first world record of producing shock wave human living. Okay? There is no such record that human beings can produce such a shock wave. And you are producing in 5 rupees syringe. Okay? This became, I couldn't believe it. Is this what is happening? It needs so simple. So, my friend is there, I used to bore him with all my details, and finally, we tried out all possible syringes available, and this became an obsession in the laboratory. And then finally I realized this has a potential to become world famous and do many things. And that's how I call this as a Reddy tube. I patented this as a Reddy tube, not to say that it is K.P.J.Reddy, a generic Indian name. Remember, sir, if a textbook is opened, how many Indian names you see? So I want all the world engineers to read this and say, hey, this is an Indian invention. So therefore I named it as a Reddy tube, and it's a generic name, and definitely it will be okay? Now you can say, so what? You produced the world record. What is the use of it? Let me show you. So we have made different size of it. For example, these things now I have modified a little more. Now let me see, what is the use of this thing? Remember, I said I am a farmer. I will be always looking for something. When I was a child, we used to take this buffalo for, crossing, veterinarian will come. Now they have a artificial insemination. The doctor will charge you 500 rupees and he will put an insemination. And they use the artificial insemination gun. They insert into the uterus, and the semen is deposited at the entrance of the uterus. And this gun works very simple. He has a rod here, and the semen in a plastic container is put into that, and all that you need to do is push that rod. It will push the semen into the uterus. But the problem here is this. This sperm which is sitting in there has to swim all the way to this point. About 20 centimeters it has to swim. and while doing it, it will die. That's why the success rate of a pregnancy is only 35%. Therefore, a cow, my farmer, has to go thrice or 4 times before the cow becomes pregnant. And before he comes to know that it has failed, it will be 1 month. That 1 month, every day, cow is eating 5 kilo of busa. Okay? It's not producing milk. Now integrate, sir, you are talking of trillions of dollars lost per year. If you can alter this by few percent, you are changing the GDP of the country. Okay? This is the thought process. So all that we did was, we removed that rod, okay, and introduced the tube, same diameter tube, and connected the ready tube to that. Simple ready tube, 5 rupees syringe. Now everything is same. All that the doctor has to do is, this is the modified ready tube. I have called this as a super bull for one reason. The semen is not going drop by drop now. It is spraying. You can see the spray. Okay? You push a shock wave, it will go and hit the semen, and the semen goes deep into the uterus all the way as a spray. Okay? Now, the success rate of this should go up at least about 20%. Okay? This is what really will be the game changer for the dairy animals. And all this is possible only because ready tube is invented. And I have named this as Super Bull for obvious reasons. And credit must go to my friend. He gave me the idea. Okay, now this ready tube is so simple. You remember, in another about 10 years, Robusta coffee breed will be out of this country because the borer disease has come, it is killing the plants. 40 years, 50 years old trees, even mango tree in polar areas are dying because these borers are entering, they are killing the trees. So there is no way that we can solve this problem. So when the coffee board approached us, it is so simple. All that our boys did was, they put a ready tube into that channel. Okay? See, you have a hole where that fellow has entered and put just one shock into it. All that it does is the high pressure wave goes, and because of that pressure, and this larva, this fellow, it becomes pulp. It just gets crushed. Okay? And this is one of the applications we are talking about. So you may save this crop ultimately. Okay? Again, it is, because of the ready tube. Now this ready tube has gone into avatars, So, can I ask my friend to show that ready tube, that plastic one? It is so simple. Please go home. While going, you buy the syringe and start playing. You can even, this is the simple. It's a typical syringe. You just put a diaphragm there. You will just fire. You will not even hear much of a sound. That's it. Over, you have created a shock wave. Believe it. This shock wave, if you had blocked at the other end, it would have produced 800 degree Kelvin temperature by hand. Okay? Now with that 800 degree Kelvin, you can even make a laser, carbon dioxide laser out of it by hand. Okay? You can fire and fire. Okay? Then, before I go to the bigger ready tube, I want to show you, this is a 4 millimeter ready tube. Instead of hand, I can drive it with little pressure. The beauty is, we just put a bullet there. Bullet means a Teflon bullet, small one. You know what is the velocity the fellow came out? At 800 meters per second it can come. And if I put little higher pressure, I can make it 2 kilometers per second, more powerful than any rifle around. And no sound anywhere, no explosive, nothing. You can kill a fellow 1 kilometer away. Silently you can finish. Okay? But that's not the intention. The intention is, don't think I am always a killer. Intention is this. If I can combine this, I want to give you an idea. Tomorrow, already people are booking hotel rooms in space station, they have rooms. $10,000 is the booking charge. Hyderabad, they sell anything and everything. They are booking the rooms. When you go there, you need water, you need rice. You cannot, if you want to take 1 bottle of mineral water to space, you are spending 11 lakh rupees is the cost. So you and me cannot afford that. But I want to take it to a common man. How do we do that? If I can, why this bottle should go in a rocket? Let us throw it at a velocity. If you want to throw it, you need 9 kilometers at least per second speed. How do you generate that? So here is the idea. All that you need to do is connect the ready tubes. Okay? So now you have a thing. So when I was doing, one German specialist came, he was the top-notch guy on shockwaves. He said, hey, K.P., you are really wasting time, it will never work. So we took a bet. If it works, he said, you will give me a biggest wine bottle. Okay? So look at the way. When we fired with a single one, you can see, I took the photograph, there was no emission of light because the temperature was not good enough to ionize the gases. When we fired 3 of them, you can see blue light coming out. What is the meaning? They combined together and the temperature went up beyond 5,000 degrees Kelvin. That means I can combine them. So if I can combine them, 10 of them, 9 kilometers is not a problem at all. Then I can put a water bottle there in a big bottle, fire it, you go to space. So you see, I have, and I named this as Trident. Trident is the name of it. But I stopped all the work because the objects flying at those velocities will kill people. They just, you need a range for that, you need a special arrangement. So the message is, simple inventions can take you to places. Okay? Then, this is the another one. So, ready tube should be made available to students to learn shockwaves, isn't it? Otherwise, your BSc, you cannot put this syllabus. So therefore, my dream is to put this syllabus into first year physics at engineering and science level, all over the country, all over the world. So we built this ready tube. Now we can fire and show. Can you do that? This is a simple tube. Again, it is like a syringe. Okay? We have a diaphragm sitting in there at this point, and from one side, here's a syringe. Look at this. Can you imagine? By hand, you have produced the strongest shock you can think of it. It is not pataki, it is just pressure. And this is the ready tube, sir, available to you. And you can learn all gas dynamics with this. Okay? And now we are going to market already some universities in America and England are teaching this. And this will be available, 2 lakh rupees at least we will be marketing. We have started a company. So this will become a sort of a first year physics laboratory. Now the students can do, if you block this end, that sound will not come, but temperature go to 1200 degree Kelvin inside. With that you can do chemistry, you can do a laser science, you can do whatever you want to do. And we are going to start with Niman's people, work on the rat brains using this facility. So this is the invention strength, okay? Then this ready tube, I want to send it to the teaching hypersonic. Remember, if I put a nozzle at this end, it should become hypersonic. This is the world's first hand-operated hypersonic shock tunnel. Okay, it is producing same characters as the big tunnels, what I showed you. Now this is a tool to teach. Okay, now we are going to market this across the globe for 6 lakh rupees at least. All that came out of 5 rupees syringe. Look at the money you can generate. You know what is the estimated income out of these two? Is 600 crore rupees is the money. Okay, I can earn that money. IISc has realized it. They have permitted me to start a company to market. So, for the message to the youngsters, don't get carried away by those complex quantum mechanics equations, those complex variables, those tensors. Sir, you can be simple and you can do things. Okay? Not that I am saying they are not to be studied. Okay? Now, I said, how much more time? Please, any one of you say, I had enough, so I will stop. So I said, hey, what is the use of my doing all these things? I have my mother-in-law who is close to 80. When she wants to cook Karela, this agal curry, she cuts it in the evening, puts marinates it for the whole night, morning she will wash it, then she makes it. Otherwise it's too bitter. So I said, we need to do something about it. So what we did was, so you just take a shock tube, take a small container in a water, containing water, put your Karela or apple into that. then put a small shock, connect that to this fellow. Okay? Just press it, that sound now doesn't come, it goes in there. So now you take your apple out, you will see apple has no damage on the surface, but now you can stick a straw and drink the juice out of it. Okay. And you know why this came up, the idea? There was a terrorist attack in Israel, a school bus was attacked, all the children died. Driver was holding the steering with a smile on his face, no damage on the body, nothing. The driver still was a smile, but when they took out, he was dead. Then when they opened his stomach, they found all his intestine had become pulp. So what happens is when the shock wave goes into the body, it gets amplified in the liquid medium. That's what has happened here. Once it goes into the apple, the skin is not damaged, but in the apple, because there is a liquid sitting, it amplifies, all the cells will rupture. The juice is released. So now you put a Karela there, now you can see this. This Karela is no bitterness. All the juice has come out. Okay? So this is the device which I am going to market so that every kitchen will have a Reddy tube sitting on. And how do I do that? And here is the device. My friend Murli is doing it. Look at this. This we have done. Chekli martiralva, chekli machine, chekli roll. So all that I have done is remove that plate there and put a diaphragm, attach another chamber. Now you put water into it. This is the diaphragm you have. This is a mylar sheet. You just rotate. Your grandmother will do that. So a shock wave goes in and they take the apple out and you start breathing. Okay. This I want to market into the as a kitchen appliance. So from space you can come back into the kitchen. Okay.
So the auto battery.
Okay. So this is the another contribution by a friend of mine, your old student only. Needleless drug delivery. You see, most of our cross infections are because of the reusing of the needles, and the pain you have is so much. So he has developed a shockwave assisted needleless drug delivery. You don't have to poke in anything. Just hold and press it, the drug will enter the body through the porosity of the skin. Okay. Now this is undergoing a lot of trials in the laboratory on the rats. Okay. And other day there was a question on this in the parliament, and the minister answered, Indian Express cover, Times of India, that became a big news. Okay. So this is the way this device works. All that thing is, you can inject any medicine into the mouse there, and the mouse doesn't even feel the pain. So a lot of trials are going on. This will be hitting the market sometime soon. Okay. Then, I said agriculture is our lifeline, so we are working on using these softwares to improve the seed quality, make them as resistant to drought and all that thing. Agricultural University is using our facilities. Some of them, the things are here, but that is this is the bamboo which I was showing, that this bamboo is long lasting. Now it is so hard, you can make houses, you can make furniture with that. There is endless such schemes are available now. In fact, ultimately, I went, this is the one, I think I will leave this research part of it. I want to show you this before I end my talk. Okay, remember, as I say, I am a farmer. I went to my village about 6 months ago. My cousin said he had sold his banana plantation, 3 acres. He needed to irrigate once more before he got the 3 lakh rupees or 4 lakh rupees. But the borewell gave up. So he lost the crop. So then I felt, how can we increase this borewell yield at least by 10%? Then it will save the farm. So we came back. This was, I think, February or March we did this. All that I did was, we took this, all my students and colleagues, we took the shock tube, went into a dry borewell, sent a shock wave into the borewell. First shot you can see, borewell is 100 feet deep, and this mud is at the bottom of 100 feet, and this fellow goes in and brings all the mud down. Okay? And then after some time you can see water coming out of it. That means Really what it does is the pressure acts on the sides, and whatever those small holes which was bringing water got blocked and the borewell drive will open up now. Okay? This is another patent which we are doing. But the long story of this is, future of the energy needs will be met by a gas called methane. This we have to extract from about 3 kilometers below the ground level. And America is extracting this. This is called shale gas. And if you need to pump in millions and millions of gallons of water to take that out. And remember, where is this water available to you? India has enough deposits to last for another 50 years. But you cannot take it, no water, no technology. And they put chemicals into it. So it is damaging the aquifers, damaging the underground. So therefore, we have modified this technique in such a way water is not needed. This technology, as on today, my suspicion is in another couple of years, may make India as one of the richest countries in the world. Okay. So this is again shockwave. We can send in shockwave into 3 kilometers to ground, okay, and explode that, make that gas to come out, suck the gas out. Technology is in place. And our technology has moved into tea industry. Now I can dry the tea instead of 16 hours, in 1 hour or half an hour, I can clean it. We are going to build a huge shop tubes in Nilgiris. So there is no limit to these things on earth. And we have proved it that we can do this. And it is a simple technology, but we need to spend time. And we have proved that the ordinary person, as I repeat, 35% wala, can do it. So people coming out of this glorious institute, National College, I cannot imagine what all the things they can do. See, you have the potential, you have the capability. Open up your mind and see that you can do it. With this, I would like to say thank you very much for listening to this.